Electrical energy should be safe and controlled. Production plants in heavy industries have an enormous potential of electrical energy. The most important thing is to have safe energy distribution systems. The smallest failures could cause great damages. In case of a failure, within the first 5 milliseconds, current and magnetic forces reach their maximum. Within 10 milliseconds, the maximum value of pressure follows, while the temperature rises steeply and uncontrollably. 5 milliseconds is a very short time, so extremely so that in this period, a bullet shot by a heavy firearm is able to reach a distance of 4 meters only. Any action to drastically reduce the destructive effects of an arc fault must be taken in less than 2 milliseconds. This is what the Arc Fault Limitation System ARCON, developed by Eaton, accomplishes. For personnel safety, most of the industrial companies defined, for the operation of their electrical switchgears, 3 lines of defense to avoid accidents caused by the hazardous potential of electrical energy. That is to say, third line, regulation, using special wear and devices and following related safety rules. Second line, limitation, additional mechanical safety measures. First line, prevention, full insulation of live parts. If any of the involved physical phenomena cannot be controlled, an arc fault is likely to be expected. The very first line of defense, and the most effective one, is prevention. The heart of those systems is its contacting device, which is responsible for taking the energy from the bus bar system. Prevention means that the contacting device, the vertical bus section, and the outgoing plug make up a fully insulated whole, thus achieving an arc fault-free zone. Prevention also means the remarkable technical advantages of the pressure contacts. What makes the difference between the conventional contacting device with Lyra contacts and the innovative pressure contacts? The pressure contact choice makes it possible to significantly reduce and eliminate the undesired effects of the magnetic forces. What's more, it even strengthens the contacting pressure. One day, it will happen. Wherever on the energy line a short circuit takes place, all the energized parts will be subjected to hazardous forces. There are mainly 4 magnetic forces affecting the function of each contacting device. This will be shown in detail to get the differences between Lyra contact and pressure contact. The magnetic field between the parallel fingers of a Lyra contact explains why these kind of contacts should be outwardly safe. Parallel electrical conductors with the same current direction and similar current levels are pressed together, which is the result of magnetic fields overlapping and strengthening. The higher the short circuit current is, the higher the pressure of the contacts should be. The magnetic field between the vertical bus bars is responsible for the conductors shaking and is one interfering effect that may lead to a malfunction of the finger contacts. Short circuits up to 100 kA cause forces of 20,000 kilopond per meter. The video shows how the bus bars shake during a short circuit and how extremely the finger contacts are affected. The magnetic force between power plugs is another interfering effect that may cause a failure of the finger contacts. The impact of this magnetic field can be even more critical because, in most cases, the plug systems are simply supported to compensate mechanical tolerances only. As shown before, all forces generated by the different magnetic fields result in a contacting pressure reversal and cause unbalanced currents. The overlapping and strengthening magnetic field, which should press the contacts together, gets lost. The repulsive contact force caused by electromagnetic constriction will finally become the most critical effect, pushing the contacts away. This causes a flashing arc, which could eventually result in a greater damage should ionized gases short-circuit two phases. During the simulation of a 250 kilowatts motor start, a common typical operation, the flashing arc at the contact points already takes place. Prevention means that the contacting device, the vertical bus section, and the outgoing plug make up a fully insulated whole, thus achieving an arc fault-free zone. Prevention also means the remarkable technical advantages of the pressure contacts. There is no reciprocal movement of the parallel pressure contacts during a short circuit because of their complete phase-to-phase encapsulation. Compared to finger contacts, there is no breaking of the magnetic field between the pressure contacts. There is nearly no reciprocal movement of the vertical bus bars during a short circuit because of their complete phase-to-phase encapsulation. Compared to finger contacts, there is no infringement of the movement of the vertical bus section to the pressure contact because the contact can slide horizontally over the surface of the copper bar. Geometry and dimensions of this pressure contact ensure that the magnetic field within the U-shaped conductor generates a higher force than the opposite repulsive contact force caused by the electromagnetic contraction. The magnetic field within the U-shaped conductor of the current layer moves the contacting element forward and strengthens the contacting pressure. This kind of pressure contact has been developed together with the Fraunhofer Institutes, renowned worldwide for their research activities and finite element analyses. The contact will be always pressed further to the bus bar, no matter how severe the short circuit will be. The video shows the contacting device test at the voltage level of 735 volts, 65 kA with 400 ampere fuses. The special construction of the complete system allows the install of an internal arc fault exhaust duct at the backside of the switchboard panel. An arc fault test of 80 kA for 500 milliseconds has been successfully passed.